So let me show you the big idea. I'm using this reference book. So the main reference will be the first two, as you know, Foyer and also Patrick. All right, maybe the first one. Opium is the extract from poppy. Our concern as a pharmacist is morphine. Yeah, morphine is the main thing, the central thrust in my lecture. Okay, so this is the god. Well, this is I think you know, Morpheus, but the real Morpheus is the Greek god. Yeah, the sleep god. All right. So this is the rings of morphine. The core structure of morphine is called morphinin. Yeah. All right. And the naming is important, but there's a video on that explaining step by step how we can name. So you see later. Yeah. I'm breezing through. The way morphine usually represented in my lecture would be in the bird-like structure. The wings on the side and the middle of the body. All right. You probably also have the previous year's lecture. No change at all. You can use that if you want to. Important thing is that if you remember your aromatic chemistry, morphine can undergo radical formation, and actually at the end it will form. This one to be we write with 1 to form a dimer. So when it forms a dimer, what happens is it's no longer potent. It's no activity as a dimer. Yeah. So if you expose morphine to extreme condition, hot, heat, and so on, this will happen. This is when you see your morphine ampule doesn't even have any effect at all. Okay. So it should be kept under closed container. Yeah. Should be kept in the closed container to avoid exposure to oxygen, to air. Right. The essential one that you have to know, yeah? Make sure you know this. Okay. Firstly, this is the peripheral modification. So morphine would have two types of modification. The ring modification. The ring would be the big rings here. It be changed or it be removed. Or now we're talking about peripheral on the sides only, just here or there. That's all. Yeah, I'll talk about the ring in a bit. Firstly, you have to know if you take the R group, change that to a methyl, ethyl, and so on, the analgesic property will reduce. Okay. Yeah. So basically, it's not this modification is not tolerated at all. Right? Once reduced, then you can use, for example, codeine to use it for cough mixture. All right. All this is available in Patrick if you want to read further. Yeah. Now, the second modification is on the other side. Okay. On this side, you can still change like the earlier one. It will improve the analgesic properties. Okay, so this one is still tolerated. There's no problem with this. Now, this is where things get heated up a bit more. Heroin. We heard of heroin? So heroin is the diacetyl modification at these two ends only. So the rest of the structure remains the same, but you have the acetyl group. Yeah. Remember I said in the second year, you have to open up the AC to see the acetyl group. Yeah. So the acetylation, deacetylation, diamorphine, heroin is very, very potent. Yeah, as an analgesic. Yeah, because it can actually, it's now more lipophilic, can actually cross the BBB better than the parent as well. At the same time, it has worse side effects. Worse tolerance as well. Easily get addicted and dependent on the drug. Just now, here is a double bond. If you remove this, it's still tolerated. It's no problem at all. Yeah. On the R1, R2, more or less increase. If you change the end, change the chirality, is not a problem really. Yeah. Now, if you change the N here into a salt, there's going to be a reduction, really, yeah, compared to morphine, we find the parents. So it is not tolerated, yeah. So overall, the one I've labeled in red is not tolerated. Any changes on that will make the property, morphine property of an analgesic suffer, yeah. The one in blues are okay, yeah. So these are the peripheral modifications that are affecting analgesic properties.